Hello, my name is Micah Briskin, and today I'll be talking about Aurora Borealis and Aurora Australis. If you're ever in the northern part of the world and see the sky illuminate in wild shades of greens and reds and blues, first of all, you're very lucky and I'm jealous, and second, that's a meteorological phenomenon that's been named Aurora Borealis, the Northern Lights. Aurora Borealis is derived from the Greek words aurora, meaning sunrise, and boreas, meaning wind. There are actually two different kinds of auroras, Aurora Borealis in the north and Aurora Australis in the south, but the much more common of the two is Aurora Borealis. This wonderful event at the center of many myths and desktop backgrounds has a strange path to becoming the dazzling colors in the sky. To understand why the auroras happen, we need to look at the sun, though not directly or we'll all go blind. The sun is a giant nuclear reactor with massive amounts of energy causing a magnetic field and energy being expelled constantly. This expulsion is referred to as a solar wind. The protons and electrons found in these winds are expelled from the sun's corona, which, besides having a completely new and unfortunate meaning in 2021, is the outermost and one of the hottest layers of the sun. To escape the sun's gravitational pull, the particles are flung at 466 miles per second and form superhot plasma, which is just electrically charged gas. The Earth also has a magnetic field. The Earth's magnetic field is like that of a magnet bar found in a classroom, with the magnetic force looping from one pole to the other, leaving a little hole at the top for wacky and spooky things like the auroras to occur. As the sun is constantly expelling energy, you would think that the auroras are happening constantly, right? Wrong! The Earth's magnetic field, called the magnetosphere, shields our planet from the solar winds and other such space particles. The magnetosphere is very durable and good at its job, except when it isn't. If the sun ejects a mass called a coronal mass ejection, the magnetosphere can't handle it, causing a magnetic storm. The magnetic storm stresses the magnetosphere, pushing and stretching it across the planet until it suddenly snaps back like a rubber band. The flinging action causes some of the detoured particles to crash through the Earth's atmosphere right into the little holes at the top and bottom of the magnetosphere, causing all those pretty colors to appear in the night sky. What causes those pretty colors, though? Well, the atmosphere is 99% nitrogen and oxygen, and when those atoms are struck by the space particles, it creates energy. The energy is enough to make the electrons of each atom fly in a wider and farther orbit around its nucleus, in a condition called an excited state. However, that state isn't stable, so the atoms in the atmosphere quickly release the energy they absorbed from being struck by the plasma particles. The energy is released as photons. Photons are little parcels of light caused by the expulsion of energy. These little photons are what make up the auroras. The colors in the auroras vary based on how much of which atoms are in the atmosphere when the solar wind hits. Oxygen atoms release at a longer wavelength, which makes the green, yellow, and red lights, whereas nitrogen releases at a higher frequency, causing blue light. The auroras are really pretty, but they can only be seen in specific parts of the world. They can be found near the poles, but for those of us who don't have expeditions to Antarctica readily available, places near the Arctic Circle will do just fine. Alaska, Canada, Iceland, Greenland, Norway, Sweden, and Finland are all great places with amazing views of Aurora Borealis. If you really want to see the southern lights, Tasmania and New Zealand have some pretty stellar seats to the Aurora Australis show. The auroras have been happening for a long time. It's not known exactly how long, but around long enough for multiple cultures to have different ideas of what it means. As mentioned earlier, Aurora Borealis comes from the Greek words aurora, meaning sunrise, and boreas, meaning wind. It's a little strange that the name comes from the Greeks, as sightings that far south are almost unheard of nowadays, but that didn't stop them from coming up with their own reasoning behind the meteorological event. The Greeks believed that Aurora was the sister of Helios, the sun, and Selene, the moon, and that she raced across the early morning sky in a multicolored chariot to declare the dawning of a new day. The Romans, who basically stole all their ideas from the Greeks, also associated the northern lights with a new day, believing it to be Aurora, the goddess of the dawn. Many of the early Chinese legends associated with dragons were also a result of the northern lights. The lights were viewed as a magnificent battle between the good and evil dragons, which each blew fire across the sky, illuminating their villages in glorious spectacle. In Japanese culture, they believe that a child conceived on a night lit up by the northern lights will be born with good looks, intelligence, and good fortune. Aboriginal Australians who saw Aurora Australis believed they were watching their gods dancing overhead and joined in. The culture that wins the prize of most interpretations of a meteorological event is the northern Native American tribes. The Cree Indians believed that the lights were the spirits of departed friends and relatives attempting to communicate with those left on Earth. The Algonquin thought it was light from a fire built by Nanabozo, their creator, and the fire was Nanabozo's way of saying that he was watching over them. Even further north, many Inuit tribes thought Aurora Borealis was the spirits of dead humans playing a game with a walrus skull as a ball, and the people of the Nunavik island thought it was walruses playing with the skull of some poor human. Throughout history, there have been a few notable instances of auroras. The skies are said to have burned a bright red in Scotland and England just a few weeks before the French Revolution, and was later thought to have been a warning sign of the coming war. The Great Solar Storm of 1859 was so insanely powerful, it reportedly caused auroras visible as far south as Honolulu, Hawaii, which is nowhere near the North or South Pole, so it must have been one hell of a solar storm to distort our magnetic field that drastically. Benjamin Franklin wrote a paper theorizing about the cause of Aurora Borealis in 1778. In 2016, a group of 50 scientists discovered a new type of Aurora Borealis and named it Steve, after the DreamWorks film Over the Hedge.
Let's call it Steve.
Steve?
It's a pretty name.
Steve sounds nice.
Yeah, I'm a lot less scared of Steve.
It later turned out that it wasn't a new type of aurora, but in fact a 16-mile wide strip of plasma interacting with the atmosphere in a cool and funky way. Whatever your belief on Aurora Borealis and Aurora Australis, there's no denying its stunning colors and astonishing patterns as it dances across the sky. The process by which this magical phenomenon is created is often passed off as science mumbo-jumbo because it entails so much physics. Also, scientists are too busy trying to populate Mars to explain what solar wind is to you. The question then stands, is it more or less magical to know how it happens? I think more magical, because if you ever see the auroras in person, you now have a deeper understanding of exactly how far the solar wind had to come, how much strain was put on the magnetosphere, and how past generations have looked at the beautiful sight with the same look of awe.